This is the short summary for Chapter 1 in the Functional Programming tutorial. Chapter 1 was a general introduction to functional programming using Scala as the example language, with explanations of how functions are used in functional programming and how values and types are used. The main idea is that functional programming follows the mathematical tradition and treats programs as mathematical expressions, which allows to use mathematical intuition. For example, expressions such as these are written in the mathematical notation, and in functional programming are written as programs that very much resemble the mathematical notation. And I show examples in Scala how each of these programs are written. For instance, each value is immutable, as I illustrate by referring to typical practices in mathematical texts. Variables in mathematics are either named constants or function arguments, and they are immutable, and they also have a fixed type. Functions can be named or anonymous. Anonymous functions play a very important role in functional programming. Anonymous functions can be used as values and directly given as arguments to functions. I show an example of this in the Scala syntax for anonymous functions. Mathematical notation for anonymous functions sometimes can be seen in some math books, but usually is not emphasized. This is an example of a Scala collection. I explain different kinds of collections, such as sequences, sets, maps, and also how the types of collections are written. And here's a summary of different ways that mathematical formulas are represented using code in Scala syntax, or more generally in functional programming. And the most important part here is that mathematical notation, first of all, is more or less translated literally and syntactically into code. But in many cases, mathematical notation does not emphasize that there is a function or anonymous function under the hood. So for example, in this formula, the k is a letter that denotes an argument of an anonymous function, actually. This k is not a value defined outside of this formula. The n is defined outside, but k is not. And in the code, you need to make this explicit. And you write an anonymous function that takes k and returns k squared. That introduces the new argument name k. I show how that works in all of these examples in Scala code. Higher order functions are functions that take or return functions as arguments. They take functions, or as return values, they return functions. I explained that the Scala scanner library has a lot of higher order functions that are very convenient for writing programs that operate on collections. And if you do that, your code will look like mathematical formulas. I give examples that show how that works in Scala, such as to compute a product like this as function of n, or to compute a sequence that satisfies some condition. And I summarized to describe what are the class or mathematical problems or computational problems that can be solved now using these techniques. And also, quite as importantly, what problems are not yet solved because these tools are not yet sufficient, and that is mathematical induction. Mathematical induction has not yet been introduced in this tutorial, and so there are certain problems such as applying a function n times, or finding element in a sorted array by binary search. Those problems cannot be solved using map, reduce, filter, and such functions. I give exercises for the material covered.